So in this problem, you maybe read the books where you choose your own adventure. Well, here we're going to choose our method. Which one makes more sense to do? Which one's easier? So we want to set up and compute the integral here for this situation. So the two functions are y equals 2 minus x squared, y equals x squared. And we're going to take that region and we're going to revolve that about the x-axis. So I've gone ahead here and graphed my two functions. You can see 2 minus x squared here in black and x squared here in red. And of course we're taking this region here, right, and we're going to be revolving that region about the x-axis. Okay, so we're taking that region and we're going to revolve it about the x-axis. So we look to see which would be easier. Which would be easier. And so if I'm using washers, I would be measuring perpendicular to the axis. So I would do something like this. Right, and then that would just be the black function minus the red function squared, the squares of those. And that's pretty straightforward. What about if I did it with shells? Of course, I would be integrating between these intersection points here, which happen at -1 and 1. And so what I could actually do, because these two functions are both symmetric about the y, this piece over here and this piece over here are the same. So I could actually just take this region and double the volume if I was doing it with washers. Now, what about shells? So shells, we would have to measure parallel to the axis, and then we see there's a problem here. Really big problem if we did this with shells. I would actually have to, I'd have to take that y equals x squared function here and look at my different parts of that for y, solving for x in terms of y. And same thing with this one here. I'd have to be solving for x in terms of y. That's going to be a little bit of a pain with those equations as they are up there. So, and then I'd have to do actually two integrals. I'd be going from 0 up to 1, and then I have to have this wing of the thing minus its other one. Kind of messy. And then I'd have to do from 1 up to 2, and I'd have to be doing this wing of the thing as well. So you can see shells are definitely not a good option here. It could be done. It's going to be painful. Instead, we're going to try and do it with washers. Washers are definitely easier. And so that's why we have two methods, because sometimes one is easier than another. And again, so with the washers, because of this function, these two functions both being symmetric about the y, I'm going, instead of going from -1 to 1, I'm going to go with the integral from 0 to 1 and multiply it by 2. So 2, and then my pi, integral 0 to 1. And then it's going to be the difference of the top function squared. So 2 minus x squared minus the bottom function squared dx. Oh, I'm sorry, that should be x squared. Not x squared, but rather x squared dx. All right, and then you can work that integral out. And when you do, you should get a volume of 16 pi over 3. Here you can do it by hand. This can't be done, or you could go ahead if you wanted to and work it out numerically as well. Okay, so this is an example again where we're checking to see which option would we want, and far and away here in this example, washers are far easier to work with, and so that's what we'd want to work with here. Okay,